We are here with Keto from NASA at the Family Fun Zone at the Trenton Midsummer Festival. And so he's going to tell us a little bit about what we have going on here at this brand new, exciting event this year.
Good morning, Kathy. How are you today? Yeah, we're here from the NASA Glenn Research Center in Cleveland, Ohio. And we go around the country here and set up our displays to get kids interested in STEM. And we'll take you on a little tour of our tent that we have set up for you today. First, we'll start here with our spacesuit. This is a prototype or replica of the spacesuit that the shuttle astronauts used. If you pan over here, we have the info table where we have literature. We also have these cute little fun pads for children of all ages. And then over to my right here, we have a fuel cell, which they actually use on the International Space Station for separating water into its elements, hydrogen and oxygen, for use on the space station. We also have a photo booth where you can get your picture taken, and it shows you, pictures you in space. We also have a vacuum cart where we simulate what happens in the vacuum of space. We also have the Xbox, which is the Mars lander, where you attempt to land the Mars rover on Mars. We also have plenty of other activities. You can use the cutouts to get your picture taken, how high you can jump. So come on down and join us.
Thank you so much, Keto. Have a great weekend.
You too.
Thank you.
It uses the Xbox Connect, which, as most kids know, it causes you with motion to have things happen on the screen. So with this one, we're going to attempt to land the Mars rover on Mars. So we're trying to keep the spacecraft inside of the ring you see here. So for this one here, it's how high you can jump. You jump here on Earth, and we have a table which calculates how high it would relate to you jumping on the moon as well as Mars.
Hi, how's it going today? What we have here is a demonstration of what our space power technology is like, what we use to power spacecraft and different devices out in space. So what we have here is we have a light here shining upon a small solar panel here too. That produces electricity. What we're doing there is using that electricity to take water. We have deionized water here in these vials here too, and we're using that to break apart the water, basically shear it apart. A lot of times water has been referred to as H2O. So what we're doing is using an electrolyzer here to break apart the water, and these bubbles coming up are different bubbles of hydrogen right here and oxygen right here. So we have H2O, so we have about twice the volume of hydrogen as we do for oxygen. Now we're using that to generate our gases. What we do here now too is we have a device known as a fuel cell. The fuel cell actually takes hydrogen and oxygen gas, recombines it to produce electricity, and that's what's running the fan. Okay, and the byproduct for that is water vapor. So that is really what some of the technology that we used for basically the space shuttle. Whenever the space shuttle went up, it did not go up with solar rays to produce the electricity. What we used have hydrogen and oxygen tanks there and a fuel cell device, and whenever the shuttle went up for 1 to 2 weeks and everything, it would use that with the gases to actually power it. But this technology is more than just for space here too. It's used a lot at the NASA Glenn Research Center. We've done demonstrations with actual fuel cell technology on buses, where you basically charge up the hydrogen and oxygen on the bus itself, and the emissions are basically water vapor and everything. It's used quite a bit on forklift technology right now because it makes the most economic sense. Okay, what we have right here is some other solar cell technology. If you've ever seen the space station before, pictures of that, you have solar cells and solar arrays that are roughly about the size of a football field. Those actual arrays are comprised of silicon cells of this size. So this is identical to the blanket technology that's on the space station itself. It just shows you some other photos where we look at the silicon solar cell technology out there right now, and this shows some of the newer technology that is twice as efficient as the other stuff right now. This is the current state of the art.